Okay, Assalamualaikum and very good morning to everyone. Okay, so today we will talk about, we continue our subjects, okay, our topic today for CSC429, okay, which is a chapter 2 about the numbering system, which is how your data can be represented in the computer. Okay, so in the previous class, you already learned about the component of the computers, okay, the architecture of the computers. Okay, now we look into the how your data is being represented in the components. Okay, all right. So it will be related with your numbering system. Okay, now this is the overview. Okay, of the topic. You were introduced about how the number systems is related with your computer system. Okay, and then you will perform some arithmetic operations, okay, in the different numbers of bases. And we have alphanumeric representation, the binary code decimals, the unsigned numbers, and representations of the signed numbers, and how the IEEE floating point representation. So these videos will cover only some from the first introduction until the additions of numbering system. Okay. Okay, since you are learning, okay, start learning in the kindergarten, okay, until now, okay, you are always running with the numbers, okay, we are dealing with the numbers every day, okay. So when we see that the numbers, you can see the numbers 1 until 10, 1 to 100, 1 to 300, okay, that's numbers is we call as decimal numbers, okay, which is a base 10. So the base 10 number representations, okay, now we that's why we can fingers, okay, so kita boleh kira, okay, jadi kita boleh kira 1 sampai 10, 10, 11, 12 dan seterusnya. So bila kita biasa pakai nombor numbering system, okay, kita boleh nampak penggunaan number tu dalam kehidupan kita sehari-hari. Okay, jadi dalam ni kita akan tengok bagaimana nombor biasa, okay, dari base 10 ni, macam mana dia bertukar menjadi nombor di dalam computer system. Okay, and the natural representation for the normal kita pakai kat mana? Kita banyak pakai untuk financial transaction. Okay, kita nak buat cap paying kita punya banking. Okay, so banyak. So sometimes waktu kita beli barang pun kita ada floating point number. Okay, which is can be cannot exactly represent RM1.20 gitu So even they have a carry in the scientific notation. Okay, kalau yang complicated, kita akan tengok number tu dia akan have a scientific notation. Okay, with 1.5213 times 10 to the power of 4. Okay, yang ni kita boleh nampak kat mana? Kita boleh nampak dia dekat dalam kita punya calculator. Okay, so kita hari-hari kita deal dengan this kind of number. Tapi dalam elektronik, okay, susah kita nak simpan numbers base 10 ni. Okay, yang kita nampak, yang kita type tu is the numbers. Okay, basically bila dia dalam komponen, bila dia dalam hardware, okay, dia bukan lagi dalam the number base decimal number yang kita nampak. Dia akan bertukar menjadi satu number yang lain, we call a numbering system. Nanti kita akan tengok dalam binary number. Okay, sebelum ni kita tengok computer, the first computer, okay, electronic computer is ENIAC pun, okay, they use the color sebab dia nak dealing with the decimal number dulu, dia perlukan 10 the vacuum tubes. Okay, untuk 10 digit number tu, dia perlukan 10 vacuum tube. Bayangkan kalau dia nak buat calculation yang besar lagi. Untuk 1000, 2000, okay, 100,000, 1,000,000. Okay. Right. So, therefore, okay, it's very hard for you to transmit, okay, data for using decimal numbers, okay, and very high precision, okay, untuk encode pula 10 signal levels of the single wire, okay, so it's very difficult for you to use this decimal number, okay, for secara electronically, okay, di dalam komponen computer, so it's very messy. Okay, to implement digital logic functions dalam base numbers. For contoh addition, multiplications. Okay, kita nak komputer kita cepat processing. Bila you punya computer processing you menggunakan number yang quite big, okay, it's very hard for your computer in order to process, okay, your computer much faster. Okay, so that's why dalam topik ni you akan nampak, okay, beberapa numbering system, okay, that being used by your computer. Okay, antaranya ialah binary representations. Okay, how your numbers is represented in the binary number, or we call it as a base 2. Okay, so they represent in the digit of 1 and 0. So the electronic can be implemented much easier using a base number because they are representing into 2-digit number, which is 0 and 1. And easy to store with the bistable element. Okay, ini secara electrically, okay, macam mana the signal, okay, data and the some signal tu dia akan masuk ke dalam komponen, and then dia tak perlu, it's easy to transmit and reliable for you to transmit on the noise and accurate wise. Okay, alright. That's why kita katakan electronic, okay, is electronic devices. Komputer tu sebagai electronic devices. Sebab semua data, semua semua data yang ada di dalam komponen komputer di dalam komputer adalah menggunakan digital. So dalam digital system, the number will be represented in the bits, okay, with the smallest unit of data. So the bits is represented from the binary digit. So it is a single digit in the binary number. This is represent 1 or 0. And inside your computer, you can think of the bit as a being mechanical switch. Okay, dia macam, that's why dia lebih mudah. That's why digunakan ni, sebab sebelum ni you dah belajar di dalam komponen komputer, all the ICs is represented by the transistor. So resistor, they have two possibility, on and off, yes or no, okay, 0 and 1. So that's why they can use, that's why they use a binary number or the digit number in order to switch on and off, okay, for your electronic components. Okay, selain daripada bits, okay, we also have the byte. So byte ni actually is the bit, is the 8 bits of group together. So you have a 8 bits, you have a 8 bits that we group and store, okay, in one we call as a byte. So one bit is 1 byte equivalent to 8 bits. Okay, so when they store the values, the numbers, okay, so the 8 bits can be between 0 and 255. Okay, so they counts with the 256, but it start with the 0. So the combination of 1 and 0 to choose, okay, sama ada dia start dengan kosong ataupun 1 bergantung. Tapi dia punya the maximum values for the 8 bits adalah 256. Okay, so the values will start from 0 until 255. So the original intention was that 8 bits would be enough to assign a unique number and a very possible language character. Okay, sebab kita one character can represent by the 8 bits or 1 byte. Okay, we can count it as a 1 byte. Okay, another definitions okay, about the numbering, okay, about how your data can be represented is by words. So words actually a data can be handled by the processor at a time. So berapa banyak words it can be handled and can be processed by your processor dalam satu masa. Okay, so the most common word size, okay, adalah 8, okay, 8 words, okay, 16, 32 and 64 bits. Okay, dia bergantung kepada processor. But nowadays, kita tengok kita punya processor is covered with the 32 bit and the 64 bits. So that's why you punya processor, you akan tengok processor you boleh ada 32 bit ataupun 64 bit. So they were dealing how your processor can handle the data at one time. Okay, kalau dia 32 bit, so the number of 32 bits sahaja yang dia boleh proses dalam satu masa. Kalau the processor with the 64 bits, means that dalam satu masa dia can handle your data in the 64 bits. Itu maksud dia. Okay, this is how your data can be presented. Okay, so 1 bits, either is 1 or 0. When you group together in the 8 bits, it become 1 byte. And so, and 1 words is combinations of 2 bytes or 16 bits. Okay, right. So one word is equivalent to 2 bytes or equivalent to 60 bits. So ini kena faham istilah-istilah bits, bytes and words. Okay, alright. Okay, this is the number basis, okay, that we will introduce to you. Okay, decimal number is normal number that you already learn, okay, how to use it. And then now kita akan tengok how your data can be presented in the binary form, in the octal and also the hexadecimal, termasuk the floating numbers. Okay, so the float numbers is also included. That's why when you are doing your coding and when you are doing your programming, so when you do a code, okay, that's why you have to declare the variables. Okay, so the variables, the numbers itself have the range. Each of the range, they have a different color. Float, okay, they have a range. Double, okay, they have the range there. Okay, long integer, for example, they have a range of the values or numbers that can be did when they do the processing of your code. Okay, alright, so these are numbers of bases. Okay, so how the numbers of bases in the decimals, okay, in the binary, okay, in the octal and also the hexadecimal. So binary is a base 2, octal is a base 8 and the hexadecimal is a base 16. Okay, so kalau kita tengok dekat sini, this is a decimal number. So the binary, okay, you have 0 and 1 sahaja. Okay, untuk octal, they start with the 0. And then because the base 8, okay, so the maximum is 0 to 7. Okay, the sama macam decimal number. Tapi apabila dia start dengan dengan 8, nombor 8, okay, in the octal basis dia bukan lagi 8. Okay, dia akan jadi 1, 0. So dia akan reset the left one to 0 and they put the additional digit, okay, in your left. Okay, so they have 1, 0. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7. Sampai sini je. Bila dia 16, 1, 8, dia tak ada 1, 8. Okay, dia akan start back with the 0 and put another additional on your left side of the digit. So, dia jadi 20. Okay, never mind. Kita akan tengok macam mana how it can be generated. Okay, and then the hexadecimals, okay, you have a base 16. Okay, base 16. So, you have base 16. So, they start with the 0. Okay, the numbers until 15 is same. Until the 15. But, unfortunately, dalam hexadecimal, okay, the 0 to 9, okay, are same as your decimal numbers. Okay, but start with the number 10, okay, nombor 10 ni, okay, dia akan start with the letter, okay, which is A, represent by 10, B, represent by 11, C, represent by 12, D, represent by 13, E, represent by 14, and F, represented by 15. Okay, so if dia nak buat 16, nombor 16 macam mana? So, nombor 16, dia akan reset back 0, and then dia put additional F, 1, 1, 0. Okay, sampai dah habis. Okay, alright. Kita akan pergi go through macam mana kita nak generate, how to convert from the decimal to binary, how to convert decimal to octal, okay, how to convert the decimal to hexadecimal, okay, and vice versa. Okay, alright. Okay, now we look into how we convert, okay, our decimal number to the binary. Okay, so in order to convert binary to the, okay, decimal to the binary, you have a two ways. Okay, you can choose either way. Which is one more comfortable, either using a placing value method or using a division method. So placing value method is based on the basis either using a binary, octal or hexadecimal. Okay, boleh pakai untuk other basis, but it's quite difficult. Okay, susah sikit. Okay, alright, and division method is, okay, generally can use any basis. You nak base 5, you nak base 7, you nak base 12, you nak base 3 ke, ataupun you nak base 4 ke, pun boleh. So, division method is more general, okay, to use in, you can convert any decimal numbers to the other bases. Okay, we continue the second videos. Okay, the second video are more towards how we convert the decimals numbers into other bases. Okay, for this night, okay, you will know how to convert okay, the decimal to binary using a tables, or we can say as a placing value method. So in the conversions of the decimal number to the binary, what Yesha you need to do is you have to do some table, provide the table. Okay, sebelum tu saya nak bagi tahu, when you write decimal numbers, it's okay without the bases. Okay, so kalau 87 ni without the bases is okay. Alright, kalau tak ada bases, ada bases sama je. Okay, maksud dia adalah sama. Okay, 105, 105 based on base 10 pun boleh, ataupun 105 sahaja pun boleh. Okay, untuk decimal sahaja. Untuk binary, octal dan hexadecimal tak boleh. You kena letak the bases, because different bases have different values. Okay, alright. Untuk 87, macam mana nak sebut pun berbeza. Okay, kalau decimal number kita boleh sebut 87, 105, 2000, 211. Okay, so that is the decimal number, which is the normal number that you already use every day. So that's why there tak ada basis pun boleh diterima. Okay, tapi untuk different basis you have to write the basis. Okay, so for example here kita akan tengok macam mana kita convert 87 base 10 ni, okay, kepada binary. Okay, untuk placing value method, you mesti, the rule of thumb dia, you kena start with the from your right side. Okay, so whatever the numbering system, you must start from the right side. So in the right side, okay, apa you kena buat, you provide a table. Okay, so they provide the table, and then inside the table, okay, in the first row from the right, okay, you kena letak the values of the bases too. Okay, for example, how we got 1? 1 is actually the equivalent to the power of 0. Okay, to the power of 0 equals to 1. Okay, and then, alright, you have to the power of, okay, you have to the power of 1. Okay, you dapat to the power of 2. Okay, sama juga dengan 4. 4 is to the power of, okay, sekejap, saya ni sikit. Okay, bagi kamu nampak. Okay, so 4 is actually to the power of, okay, to the power of, okay, to the power of 2. Sekejap saya punya writing ni dia tak berapa nak gini, tak boleh nak function. Okay, which is represent to the power of 2, which is 4. Okay, and sama juga dengan 8. 8 is actually to the power of 3, so equivalent to 8. 16 is to the power of 4, is actually to 16, and to the power of 5 is will be 32, and 64 is to the power of 6. Okay, so berapa banyak you nak letak? Okay, so berapa banyak nak you get, okay, 87, the nearest numbers dalam base 2 adalah 64. Yang paling hampir. Kamu boleh buat lagi. Kalau 64 kita ada lagi 128. 128 is to the power of 7. So that's why kita tak ambil to the power of 7. Sebab 128 dah melebihi nombor yang kita nak convert. Jadi kita akan convert, kita ambil the nearest number, which is the nearest number of the 87, which is 64. Okay, alright. We boleh tahu kan nombor yang paling hampir dengan dengan nombor yang paling hampir kan. Okay, so you stop sampai 64. Okay, so 87. So dalam base number 2, okay, ini we call the value 1, 2, 4, 8, 16, 32, 64 ni, dia adalah value of the base. So kalau kita nak tahu 1 is to the power of 0. Okay, 2 to the power of 1 is 2 to the power of 2 is 4 to the power of 3 is 8 to the power of 4 is 16 to the power of 5 is 32 to the power 6 64. So 64 is the nearest number on the value of 2. Okay, by nearest to this, this 64 is the nearest, the values that nearest to the 87. Okay, so kita ambilkan 64. So now, what shall you do? Dia dah dapatkan value dia. Okay, so apa yang you perlu buat adalah you on sahaja nombor-nombor yang diperlukan and then supaya you boleh dapat 87. For example, okay, your maximum kat sini adalah 64. Of course, 64 you akan onkan dia. Kita letak 1 kat sini. Okay, and then we add, okay, another numbers. Kalau 64, okay, kita tambah 1 lagi kat sini boleh tak? Okay, sebab 64 campur 32 dah 96. So, kita offkan dia. Okay, maknanya tak sesuai lah. Okay, dengan kita onkan 32 ni. Okay, next, kita cuba ke bawah lagi. Okay, kita ke bawah lagi, kita cuba letak on 16. Okay, kalau kita on 16, okay, on tu maksudnya 1 lah. Okay, 1. So, 64 campur 16 adalah sama dengan 80. So, dah okay lah. So, kita tambahkan the values ni basically. Bila kita onkan that particular values, then we have to add. So, 64, kita onkan 64. Okay, kita onkan 16. So, 64 plus 16 is basically dah 80. So, it's quite close dah dengan 87. And then, we remaining another 7. Betul tak? So, remaining 7, kita just on. 8 kita tak payah on. Sebab kalau kita 8, dah jadi 88. So, that exceed to the nombor yang sepatutnya kita convert. So, kita offkan 8. Dan how about 4? Kita on 4. 80 campur 4. Okay, 84. Okay. And then kita onkan 2. 84 campur 2 dah 86. And then kita onkan dekat value number 1. So, dia jadi 87. So, how you write the numbers? So, you write the numbers from the left to the right. Bila you letak placing value, right to left. Bila you write the numbers of the mari, must start from the right. From the left to the right. Okay. Okay, bila kita write the answer should be here. Okay, so your answer should be 1010111 base 2. Okay, alright. Boleh faham? Okay, tak apa. It's okay. Kita buat the next one. Okay. Alright, untuk 105. Okay, so 10 is quite far. Quite high number. Betul tak? So, kita nak letak. Kalau kita tengok, oh, boleh 128 tak? Tak sampai. Okay, so kita hafal lah. Kalau boleh, kita boleh memorizing. Okay, we start with the 1. Again, kita akan start raising method menggunakan sebelah kanan. Okay, kita on and off je. Okay, so kita akan on kan. So, daripada kanan, 1, 2, 4, 8, 16, 32, 64. So, how we get this value number? Actually, to the power of 0 represent of 1. To the power of 1 represent by 2. Okay, 2 the power of 2 represent by 4. 2 the power of 3 represent by 8. Okay, 2 the power of 4 represent by 16. 2 the power of 5 represent by 32. And 2 the power of 6 represent by 64. Okay, alright. So, bila kita nak onkan ni, kita start dengan yang paling besar. Supaya kamu boleh mudah faham. Okay, so we on with 64. Okay, 64. And then kita onkan 32. Sebab kalau kita campur 64 campur 32, dia dah jadi 96. Betul tak? Okay, so tapi cukup tak untuk 105? Belum cukup lagi. So, kalau kita onkan 16, dia dah terlebih pula. So, kita offkan dia. Okay, and then 8. How about 8? Okay, 96. Kita onkan 8. Boleh tak? Boleh. Okay, dia dah jadi 104. Okay. And then, untuk 4 dan 2 ni kita off lah. Tak boleh dah melebihi. So, kita onkan 1. So, dia akan jadi, campur lagi 1. Dia akan jadi 105. We talk here is about the value. Okay, kita bukan nak value ni. Kita nak equalkan value ni supaya kita boleh dapat the binary number. So how will you write the binary number? So 1, 1, 0, 1, 0, 0, 1 base 2. So this is how the placing value method. Okay, bila kita nak start calculate, kita nak start with the placing numbers. Okay, base 2 mesti start daripada kanan. So where you stop? Sampai the nearest number. Okay, yang paling kurang lah. Jangan paling besar, yang paling kurang. Okay, and then after that you buat some additional. You on that number, okay, put some additional number. Okay, additional. Okay, so you kena add. Okay, on nombor yang bila you tambah, dia akan get to the nearest to your numbers. Okay, yang dikendaki. Okay, so this is how you convert using a placing value method. Okay, now, okay, the other method adalah menggunakan division method. So, you convert the decimal to the binary numbers using a division method. Okay, yang ini, any basis boleh. Kalau you divide by base 4, divide by 4 lah. Kalau you divide by, kalau dia nak base 6 ke, you divide by 6 lah. So, dalam case ini, dia nak decimal to the binary. So, you have to divide your decimal numbers with the numbers of 2. So you divide lah. So bila you divide, okay, you divide. So this is 87. So 87 divide by 2. Okay, you got the punya quotient numbers. Okay, the answer. And you have the remainder. Okay, so then these 43 numbers, you divide lagi by 2. Okay, so you dapat the answer. And you have a remainder of 1. And you continue divide. Okay, get the remainder. Okay, for every time when you do the divisions until your answer is 0. Okay, bila answer is 0, okay, with the remainder, so the way you write the numbers is from the bottom, okay, from the bottom to the top. So bila buat division yang kena hati-hatilah. Okay, bila division you bahagi macam biasa, okay, dapatkan dia punya remainder. So bila you write the binary number, the binary not start from the top to bottom. Nombor dia akan start from the bottom to the top. Ambil reminder dia. Okay, reminder dia. So dalam case ni, reminder dia is start from the bottom, okay, which is 1, 0, 1, 0, 1, 1, 1. So this is the numbers in the base 2. Okay, alright. Boleh faham? Okay, so kita bahagikan. Okay, kita bahagi. Gunakan cara pembahagian. Okay, so now kita ada 105, okay, 105, and then you divide by 2. So the 105 divided by 2, you got 52, and you have remainder of 1. Okay, and then this 52, you divide lagi by 2, okay, you akan dapat 26 with the remainder of 0. And then this 26, you divide lagi into 2, you got 13, and the remainder of 0. And the 13, you divide by 2, you equal to 6, and the remainder of 1, and you do the division sampai you punya answer is 0. Okay, sampai answer you 0. Okay, sampai answer you 0 kat sini. Okay, then you have to stop. Okay, I get the remainder. So when you write your answer, you should write answer from the bottom to the top here. Okay, right from the bottom to the top. So 1, 1, 0, 1, 0, 0, 1. So this is your answer of the binary of 105 in the decimal number. Okay, this is answer of okay, for your 05 that you convert into a binary. This is one binary number for 105. Okay. Alright, so this is how your conversions of binary numbers. Okay. Alright, so when you convert the decimal numbers to the binary, okay, you have a low. Kenapa kena write? Kena tulis daripada bawah ke atas. Okay, bila awak bahagi bawah ke atas, daripada from the bottom to the top, okay, you are writing the numbers of from the MSB is most significant bits to the least significant bits. So meanings that in the binary number, the right one, the rightmost of your bit is your least significant bit. Here is your LSB. Okay, the LSB, and this one will be your MSB. Okay, LSB is the most significant bit. Okay. Okay, and 1 is the, sorry, MSB, not D. Okay, and LSB is least significant. Okay, is significant bit. Okay, so least significant bit is always on your right side, on rightmost bit, and the most significant bit is on your leftmost bit. Okay, so you have to write the answer from the bottom to the top. Okay, so that is how you convert your decimal numbers to the binary. Okay, so sama jugalah kalau kita pakai placing value method tadi. Okay, bila kita tulis daripada kanan ke, daripada kiri ke kanan. Okay, sebab you buat daripada secara melentang, jadi you baca dari kiri ke kanan. Kalau you buat division mesti daripada, you write the answer should be from the bottom to the top. Okay, kita continue dengan the next slide. Okay, how we convert decimal number to the binary. Okay, tadi sebelum tu kita convert the numbers, okay, decimal numbers, okay, without the floating numbers, okay, tanpa nombor perpuluhan. Okay, now kita akan tengok macam mana di dalam komputer akan simpan your numbers, okay, in the floating numbers in the binary form. Okay. Alright, it's a normal calculations, okay. Cuma dia perlukan certain step. Okay, the first step is you have to convert the integer into a binary by using a method. Okay, alright, here. And then you convert the decimal points to the binary by using the following method. Okay, alright. So in this slide, okay, you will convert, okay, alright, so you convert the 37 ni. Okay, biasanya kita akan splitkan this 37 ni. Okay, kepada before floating. Okay, this is the numbers. Okay. Okay, this is the numbers. Okay, before floating. And this is the number floating. Okay, alright, after floating. Okay, so the numbers is before the floating and after the floating. Okay, so sebelum ni kamu dah belajar macam mana nak convert numbers, okay, this integer number. Yang nombor sebelum floating ni macam biasa, sama ada you pakai, okay, you pakai placing value method atau pakai division terpulang. Okay, yang di sini saya akan nak tunjuk bagaimana nombor perpuluhan ni, which is 0.6875 ni. Okay, 37 ni kita biarkan, kita tahu dah macam mana nak convert sebab dia lebih mudah. Okay, tetapi kita nak tengok macam mana 0.6875 ni. Okay, kita nak convert into a binary, nombor selepas titik perpuluhan ni. Okay, the first thing the decimal point numbers. Okay, the decimal point numbers. Okay, this is decimal point numbers of float numbers. Okay, the floating point numbers. Okay, whereby this number, when you nak convert into a binary, what shall you do ialah, you ambil nombor the decimal point numbers, which is 0.6875, which here, you have to multiply by 2. Okay, you multiply by 2. Yang ni kena manually, tak ada calculator. Okay, kalau kamu nak convert ni, tapi kena tunjuk jalan kerja dalam exam, dalam test ke apa, bila buat conversion, you have to show the answer. Okay, macam mana kamu dapatkan jawapan. You have to show how your works. Okay, show your works, okay, in your exam. Okay, jangan awak convert, begitu awak terus guna calculator, sertifikat kita kamu terus dapat jawapan. Untuk check tak apa, tapi untuk jalan kerja kena tunjuk. Even you are integer. Okay, untuk floating numbers or decimal point numbers, which is 0.6875, you kena calculate, you kena kalikan dengan 2. So 0.6875, you times 2, you akan dapat 1.375. Betul? So 1.375, okay, the numbers here, okay, number ni, okay, sorry, saya punya ni detect as ni. Okay, nombor ni, okay, kita ambil dia as the most significant bit. Okay, alright, kita ambil dia. Okay, so then the 0.375 you times with the 2. Okay, kat sini dia tak nampak sangat. Okay, kita type kat sini ya. Okay, 0. Okay, tak nampak ya. Okay, kita padam sini. Okay. Okay, kita buat kat sini. So 0. Okay. 3. Okay. 3. 375 you times with the 2. Okay, alright. So 0.375. Okay, you typekan dengan 2. Satu ni bagaimana kita dah ambil dia untuk jadikan kita punya one of the answer nanti. Okay, so 0.375 ni you times 2 you akan dapat 0.75. Ni lah. Okay, ni jawapan dia. Okay, better tulis macam ni sebab kamu tak nampak. So 1.375 tadi hasil daripada darab 0.6875. So satu ni the numbers before floating ni kita dah ambil. Okay, as part of the answer nanti. And then salin ambil balik 0.375 ni you times with 2. So 0.375 you times 2 you akan dapat 0.75. Okay, so 0.75 since dia punya the numbers here the answer is before floating is 0. So you ambil dia punya 0 as the answer kat sini. Okay. And then this 0.75 you times with the 2 you dapat 1.5. So 1.5. Okay. So this one. Okay. You akan ambil dia as a answer. And 0.5 tadi. Yang ni saya tunjuk kat sini. So 0.5 you times with 2. So 0.5 you times with 2 you dapat 1. Okay, you akan dapat jawapan ni lah 1. Okay, so you dapat 1.0. So 1 ni kita ambil as a answer. And this 0 dah memang kosong lah. Apa-apa jawab pun dapat kosong. So you stop lah. Okay, so you stop. So the binary numbers okay will be have okay untuk numbers after floating or decimal point numbers. Okay, when you convert into binary, okay, you akan tulis jawapan dia daripada most significant bit dia is selepas titik perpuluhan. From the left to the right. So most significant bit selepas titik perpuluhan dia start daripada atas ke bawah. Ataupun when you write down the floating numbers of the binary, your answer should be when you write your answer, you should be start from the bottom, from the top to bottom. Okay. So dia terbalik dengan tadi. Kalau yang before floating, kalau kita bahagi, kita bahagi jawapan dia from the bottom to top. Kita tulis jawapan dia. Tapi untuk yang ini, nombor selepas titik perpuluhan, when your answer is, your answer should be after floating, should be right from the bottom, top to bottom, which is 1, 0, 1, 1. Okay, so how you write your answer? Okay, 37 for example, you dah calculate, you gunakan division method ataupun placing value method, you akan dapat 1, 0, 0, 1, 0, 1. Okay, you calculate this splitly. Split, okay, splitkan dia. Okay, pisah. Bila nak jawapan, tulis jawapan, sambung, cantumkan balik. Okay, nombor sebelum floating, 37 in the binary is 1, 0, 0, 1, 0, 1 point. And how you write the answer for the after floating number from the top to bottom. So which is 1, 0, 1, 1. So this is how your answer of your decimal point numbers to the binary point numbers. Okay, so make sure you do some exercise on this because this is very important. And when you want to understand about the float numbers in the binary. Okay, sebab nanti kamu akan gunakan dia dalam pengiraan of IEEE floating point numbers. Okay, alright, kita nak tengok macam mana processor akan simpan data awak dalam when you have a float numbers. Okay, alright.